When installing electrical conduit for a pool pump, particularly using 3/4-inch PVC conduit with 6 American wire gauge wire operating at 220 volts with a 50 amp breaker, understanding the correct burial depth is crucial. This ensures safety and compliance with electrical codes. The National Electrical Code, or NEC, provides minimum depth requirements, but local codes and specific site conditions might necessitate deeper burial. Generally, the NEC specifies different minimum burial depths for residential and commercial applications. For residential scenarios, a minimum burial depth of 18 inches or 457 millimeters is typically required. However, for commercial installations, the NEC mandates a deeper burial depth of 24 inches or 610 millimeters. These depths are designed to protect the conduit and wiring from physical damage and environmental factors. However, relying solely on the NEC minimums may not be sufficient. Local code requirements can be stricter than the NEC. It is imperative to check with the local building department or electrical inspector to determine if your area has specific regulations that supersede the NEC standards. These stricter regulations often exist to address unique regional challenges like severe weather or particular soil compositions. The type of soil in which the conduit is buried significantly impacts the necessary burial depth. Rocky soil, for instance, poses a high risk of physical damage to the conduit. Sharp rocks can puncture or crush the PVC, compromising its integrity and potentially exposing the wiring to moisture and corrosion. In such conditions, burying the conduit deeper than the minimum requirement is advisable. Similarly, areas with poor soil drainage can lead to water accumulation around the conduit. Prolonged exposure to moisture can degrade the PVC over time and increase the risk of electrical faults. In regions with high groundwater levels, it may be necessary to bury the conduit below the frost line. The frost line is the depth to which the ground freezes in winter. Burying the conduit below this line prevents it from being damaged by the expansion and contraction of freezing soil. Alternatively, installing the conduit in a waterproof junction box can provide additional protection against moisture in areas with high groundwater. While the NEC provides minimums and local codes may dictate specific requirements, a generally recommended burial depth for most residential installations involving pool pumps is 24 inches or 610 millimeters. This depth offers a reasonable balance between protection and ease of installation. It's deep enough to protect the conduit from most surface level disturbances while remaining accessible for future maintenance or repairs. Beyond burial depth, several other considerations are crucial for a safe and compliant installation. Firstly, and most importantly, always consult with a licensed electrician. Electrical work, especially involving water features like pools, can be hazardous if not performed correctly. A licensed electrician can ensure that the installation meets all applicable codes and safety standards. They can also assess the specific site conditions and recommend the appropriate burial depth and installation techniques. Secondly, proper trenching techniques are essential. Use a trenching machine or manual excavation to create a clean and uniform trench for the conduit. Avoid creating sharp edges or uneven surfaces that could damage the conduit. The trench should be wide enough to accommodate the conduit and any necessary sleeving or wrapping. Thirdly, protecting the conduit and wires from damage is paramount. Consider using a sleeving or wrapping material to provide an extra layer of protection against abrasion and impact. This is particularly important in rocky soils or areas where the conduit may be subject to physical stress. Fourthly, backfilling the trench with compacted soil or sand is critical. This helps to stabilize the conduit and prevent it from shifting or settling over time. Compact the backfill material in layers to ensure that it is properly consolidated. Avoid using large rocks or debris as backfill, as these can damage the conduit. Remember that this information provides general guidance and should not be considered a substitute for professional advice. Always consult with local authorities and a licensed electrician for the most accurate and up-to-date information on burial depth requirements in your specific location. These depths and measures serve to protect the electrical systems. Electrical systems for pools may require additional protective measures, such as ground fault circuit interrupters, or GFCIs, to protect people from electric shock. Improperly installed electrical systems near pools can create hazardous conditions, including the risk of electrocution. Ensuring proper grounding and bonding of all metal parts around the pool area is essential to minimize this risk. These grounding and bonding measures create a low impedance path for fault currents, allowing the GFCI to quickly detect and interrupt the circuit in the event of a ground fault. The type of wire used inside the conduit is also important. Use appropriately rated wire for burial applications to prevent premature wear or damage to the wire itself. Wet rated wire is designed to withstand moisture and other environmental factors present in underground installations. This type of wire typically has a THWN or XHHW insulation rating, indicating its suitability for wet locations. The size of the conduit is also important. While 3/4-inch conduit is often sufficient for a 50-amp circuit, it's essential to ensure that it can accommodate the wires without overcrowding. Overcrowding can make it difficult to pull the wires through the conduit and can also lead to overheating. When selecting the conduit size, consider the number and size of the wires being installed, as well as any future expansion needs. The type of fittings used to connect the conduit sections is also important. Use fittings that are specifically designed for underground use and that are compatible with PVC conduit. These fittings should be watertight to prevent moisture from entering the conduit system. Proper sealing of the conduit ends is also essential to prevent the ingress of water, dirt, and insects. Use appropriate sealant or duct tape to seal the conduit ends after the wires have been pulled through. This will help to maintain the integrity of the conduit system and protect the wires from environmental damage. When running the conduit, avoid sharp bends or turns. Sharp bends can make it difficult to pull the wires through the conduit and can also create stress points that can lead to damage. Use gradual bends or sweeps to minimize stress on the conduit and wires. The routing of the conduit should also be carefully planned to avoid any potential hazards. Avoid running the conduit near sharp objects, underground utilities, or other potential sources of damage. If the conduit must cross under a driveway or other paved area, it should be encased in concrete or other protective material to prevent it from being crushed by vehicles. The installation should be inspected by a qualified electrician before it is backfilled. This inspection will ensure that the installation meets all applicable codes and safety standards. The electrician will check the burial depth, conduit routing, wiring connections, and grounding system to ensure that everything is installed correctly and safely. The electrician will also test the circuit to ensure that it is functioning properly and that the GFCI is working correctly. After the inspection, the trench can be backfilled with compacted soil or sand. The backfill material should be free of large rocks or debris that could damage the conduit. The backfill should be compacted in layers to ensure that it is properly consolidated. The surface of the backfill should be graded to prevent water from pooling around the conduit. A marker should be installed to indicate the location of the conduit. This marker will help to prevent accidental damage to the conduit during future excavation work. The marker should be clearly visible and should indicate the type of conduit and the voltage of the circuit. Regular inspections of the conduit and wiring should be performed to ensure that they are in good condition. These inspections should be performed by a qualified electrician. The electrician will check the conduit for cracks, damage, or signs of deterioration. The electrician will also check the wiring for loose connections, frayed insulation, or other signs of damage. If any problems are found, they should be repaired promptly to prevent electrical hazards. It's also a good idea to keep a record of the installation, including the location of the conduit, the type of wire used, and the date of installation. This record will be helpful for future maintenance or repairs. It can also be useful if you ever need to sell your home. Properly installed electrical systems are an essential part of any pool installation. By following these guidelines and consulting with a qualified electrician, you can ensure that your pool is safe and compliant with all applicable codes and standards. Always prioritize safety when working with electricity. If you are not comfortable performing electrical work, hire a qualified electrician to do the job for you. Electricity can be dangerous, and it is always best to err on the side of caution. Remember to always turn off the power before working on any electrical circuits. This will help to prevent electric shock. Use insulated tools when working on electrical circuits. This will help to protect you from electric shock. Wear safety glasses when working on electrical circuits. This will help to protect your eyes from flying debris. Work in a well-lit area when working on electrical circuits. This will help you to see what you are doing and avoid mistakes. Don't work on electrical circuits when you are tired or distracted. This will increase the risk of making a mistake. If you are not sure how to do something, ask a qualified electrician for help. It is always better to be safe than sorry. Furthermore, remember the importance of ground fault circuit interrupters, or GFCIs. GFCI protection is required for all electrical outlets and equipment located within a certain distance of a pool. GFCIs are designed to detect ground faults and quickly interrupt the circuit, preventing electric shock. Test GFCIs regularly to ensure that they are functioning properly. The National Electric Code Section 680.26 covers the bonding requirements for metallic parts. Section 680.21 covers wiring requirements. Section 680.22 covers the location of the receptacles. Section 680.25 covers the feeders. The informational notes in this section help clarify the requirements, however it is best to discuss with a local electrician and electrical inspector for specific application. If you are installing a new pool, be sure to obtain all necessary permits and inspections. This will ensure that your pool is safe and compliant with all applicable codes and standards. Permits are required for most electrical work, including the installation of pool pump electrical systems. Inspections are required to ensure that the work is done correctly and safely. A licensed electrical contractor is the best person to use. Finally, consider future expansion needs when designing your pool electrical system. If you plan to add additional equipment, such as a heater or lights, be sure to include enough capacity in your electrical system to accommodate these additions. It is always better to have too much capacity than not enough.